Okay, next we can do a problem. Actually, these problems are very important. Repeated question in your previous year question papers. Okay, question is two smooth cylinders A and B, each of diameters 400 mm and weight 200 Newton, rest in a horizontal channel having vertical walls and base width 720 mm as shown in figure. Find the reaction at P, Q and R. We need to find out the reactions at P, Q and R. So write down the question and also draw the figure. Okay, and we can solve the problem. Two smooth cylinders A and B. Here the diameter of the cylinder and weight is equal. That is similar cylinders. Okay, 400 mm diameter and weight is 200 Newton. And base of the channel is 720 mm. Okay, 720 mm. Okay, have you all completed the question? So here we need to find out reaction at P. P is the point at which the ball B is coincide or in keep in touch with the vertical wall, and also like B, A is also keep in touch with the wall, vertical wall at the point R. So we know if a body touches with any of the surface will produce an opposite reaction towards that body. We know that. So that is called a reactional force. So we can write the reactional force which is normal to the surface of the body, which is R, R, suffix R. Okay. And here RP. Also, the body B is in touch with the base of the channel. So here it is RQ. Okay, reaction at Q is RQ. Okay, you can mark this reaction, that is RP, RQ and RR. So we need to find out these reactions. Okay, so here we can draw the free body diagram of the ball. So first of all, you need to draw the free body diagram of ball A. Okay, cylinder A. So how it will be look like? Free body diagram of A. So this is the ball A or cylinder A. Free body diagram. Okay. So what are the forces or what are the reactions in cylinder A? What are the forces and reaction in cylinder A? First of all, we need to consider the weight of the cylinder. So weight will be acting in which direction? Weight of the ball A. Which direction? Weight, yes, downward direction. So weight acting downward direction. So weight is It is already given in our question, that is 200 Newton. 200 Newton. Okay. Next, we need to consider the reaction RR. Okay. The RR is acting in x-axis. So we can simply draw, this is the x-axis. We know according to law of transmissibility, we can move move any kind of force in the line of action of that force along anywhere, okay, but in the line of action of that force, okay. So the RR is acting leftward direction. So I can draw the figure like this. I can draw the force RR. RR acting leftward direction. Okay, see, so here is this is the RR reaction acting leftward in x-axis. So it is correct. Is it correct or not? So leftward direction in x-axis, RR. Also, we know any body, if it is keep in touch with any of the surface, there will be some reactional force will arise. Okay. So we know that. Also, A and B are in keep in touch. Okay. So A and B are in contact. So there will be a reaction force between these two bodies. Okay. These two bodies, there will be a reaction between A and B. Okay. So here we can write like this: the reaction force of B towards A, and also there will be a reaction force towards B by the body A. Okay, so that is RAB. And also it is in equilibrium condition, that is in resting condition. So it should be, that is RAB should be equal to RBA. Okay, we already told these things in our previous classes, that is RBA should be equal to RAB because it is in equilibrium condition. Okay, right. RAB equal to RBA. Okay, so we need to draw this RAB in this figure. Okay, RAB. So draw the RAB in free body diagram. Have you all drawn? So this is RAB. So here we need an angle subtended by the reactional force RAB with x-axis or y-axis. So what is the angle? So this is the angle. I am here writing theta is the angle. So what is the value of theta? How we can find out the value of theta? From this figure we can find out the value of theta. How? We can draw a right angular triangle by extending x and y axis of B and A. So here is the right angular triangle. So this is angle theta. Okay, actually the line of action of RAB or RBA with making with x-axis is the angle made by the line of action RAB with x-axis is taking as theta. Okay, so here it is theta, then alternative angle, this is also theta. Okay, So what is the value of theta? How we can find out the value of theta here? Tell me how we can find out the value of theta. What is the length AB? What is the value of length AB? What is the length of AB? Yes, 400. Why it is 400? Because the entire cylinder having a diameter of 400 mm. So D2, the external surface of the cylinder, should be its radius. So it is half of the diameter, that is 200 mm. Okay, then A2, the external surface, it is what? External circumference, it is 200 mm. So 200 plus 200, entire BA equal to 400 mm. Is it okay? Is it clear? So what is, if I am uh, putting the variable C as this, then what is BC? What is the value of BC here? We know, if we are considering from P to B, what is the length PB? What is PB? P to B, PB. It is also radius, that is 200. Okay, this is also 200. And considering from A to R, so what is the length here? A to R, what is the length? This is also 200, right? Sorry, yes, this is also 200. The same diameter, okay. So from C to the vertical, right vertical wall, the distance is always 200. So what is the value of BC? Here the entire length of channel or entire width of the channel is 720. Then how we can find out the value of BC? What is BC? Yes, 720 minus 400, that is 320. So BC equal to 320. So we get the value of BC and BA. Then how we can find out the value of theta? Adjacent side and hypotenuse. So cos theta equal to 320 by, here you can write cos theta equal to BC by BA, where BC equal to 200 plus 200, radius of B plus radius of A, okay, divided by BA, in vice versa, okay, 200 by 200 is BA and BC is 320, that is 720 minus 200 plus 200, okay, right? So theta equal to what? Cos inverse of that value. So what is theta? Theta value, find out the value of theta. Theta equal to what? What is the value of, okay, 36.87. 36.87 degree. Okay, so now you have to find out the value of RAB. You only need to find out the value of RAB. So find out the value of RAB. How we can get the value of RAB? Here the known value is 200 Newton. It is acting in vertical direction or y axis, acting in y axis. So under sigma Fy, okay, sigma Fy equal to 0, because the known value is in y direction, so that we can consider only sigma Fy. You need to find out only RAB. Okay, so here what is RAB or what is sigma Fy? Sigma Fy equal to the forces in y direction. We need to resolve the forces of RAB into two components. RAB, cos theta and sin theta. Okay, so sigma Fy equal to 200 is negative charge because it is acting in downward direction, and also RAB is also what? RAB sin theta. Okay, RAB sine theta. So here, what is the value of RAB? Here you can put the value of theta and find out RAB. What is RAB? What is RAB? Tell me what is RAB. You will get an answer with negative charge, okay? It means that the direction that we had taken for RAB is not correct. It is wrong. That is, RAB is acting while considering the body, while considering the cylinder ray. It is in opposite direction. We need to consider in opposite direction. Okay. That's why we get a negative charge here. So what is the value? 200 divided by negative 200 divided by sine 36.87. Okay. RAB. What is the value? Okay, 333 point. Okay, Newton. Okay, consider 3333 Newton. Okay, RAB. So then find out RR. That is sigma Fx equal to 0 implies. What is sigma Fx? What are the forces in x direction? RR acting in x direction, but it have a negative charge because it is acting in leftward direction, and also in a component of RAB. It is also acting in our free body diagram. It is acting in leftward direction. So we can put like this RAB. Okay, RAB. RAB cos theta equal to 0. Here RAB, we got an answer that is negative 333. So put the value here. So what is RR? RR equal to what? RAB cos theta. You will need to put the sign also here, okay? RAB negative 333. Then the next step in your equation will be like this: negative RR plus RAB cos theta. Okay. So what is the value? RR? Do it fast, okay? What is the value? RR value. What's the value R? RAB cos 30, cos theta. RAB is 333. 333 into cos 36.87. Yes, 26 point. You can write like this: 266.67 Newton. So RR equal to 266.67. Also like that, you will have to find out the value of RP and RQ. So for that, we need to consider the free body diagram of what? Cylinder B. Okay. So draw the free body diagram of cylinder B. So this is the cylinder B, and we are going to draw the free body diagram of cylinder B. So what are the things that we have to consider here? What are the forces we will need to consider here? First of all, you will need to consider the weight of the cylinder. It is acting downward direction. So like this. So this is the weight, that is 200 Newton acting downward direction. Okay. And also there will be a reactional force towards B acted by or applied by the cylinder A. Reaction between A and B, that is RAB. You'll need to consider RAB. So RAB is acting like this. Okay. RAB. That is the reaction force acting by A on the cylinder B. Okay, so you can also draw the figure like this. You can transfer this RAB or you can move the force RAB along the line of action. So you can also draw like this, that is RAB. Okay. And you can erase this. Okay. Okay, what is the angle? What is the angle made by the line of action of RAB and the x-axis? It is always a constant value. Okay. So here the line of action of RAB and x-axis making an angle theta. So you can also take the angle theta here also. So theta equal to 36.87 degree. Okay. The angle will not change. Always the angle of the line of action of that force and x-axis is theta here. Okay. And also you'll need to consider two forces, that is two reactional forces, that is acting upward direction and acting right hand direction. That is acting upward direction forces RQ. So you can draw like this, that is RQ. Okay, upward direction, right? Upward direction. And one of the reactional force is acting in right hand direction. So I can draw like this, RP. We can move anywhere along the line of action. Okay, so I can draw like this, RP. Okay, have you all draw this FBD? Okay, now you have to find out. First of all, you need to find out RQ. Okay, find out the value of RQ. And also you can find out the value of RP. You know the value of RAB. It is already we had done, or we had find out in our first free body diagram. From first free body diagram, it is RAB is equal to 333 Newton. Okay, 333 Newton. So put the value here and find out RQ and RP by using sigma fx and sigma fy. Okay. I think this is 36.87. Okay. Okay. Tell me what is sigma fy? Sigma fy equal to 0. Okay. Tell me sigma fy. 200 Newton is acting downward direction. So it is negative 200. And RQ is acting upward direction. So it is positive. Okay. And you will need to consider the component of 333.3 Newton. Okay. The y component. So it is y component is acting downward direction. So it is 333.3 sine theta. Sine theta is here 36.87. If you have any doubt, you can draw separately. So this is x-axis, this is y-axis. This is 333.3 Newton. The components are y component and x component. So this is the 333.3 sine theta. So here this is theta and this is 333.3 cos theta. Okay. So this is equal to 0. You'll need to find out RQ from this equation. Okay. What is the value of RQ? Tell me what is the value of RQ? Do it fast. Okay. And also you can write, okay, 399 point. Okay, approximately we can write RQ is equal to 400 Newton. Okay, right? 400 Newton. It is 399.99. Okay. So we can write it as 400 Newton. Also, you have to find out sigma fx equal to 0. Okay. Sigma fx equal to 0. Solve this equation. Sigma fx, the forces in x direction. So forces in x direction. First of all, RP. RP is acting in right hand side. Okay. Right hand side, it is positive. Okay. Also, the component of 333.3 Newton. Here it is clear that it is acting in the leftward direction, so it is negative 333.3 cos theta. Cos theta is here 36.87. That is equal to 0. Then Rp equal to 333.3 cos 36.87. What's the value? What's the value of Rp? Do it fast. What is the value of Rp? Okay, 266.67. We'll need to write the unit also, okay? 266.67 Newton, okay? Newton. Have you all understood this question? Do you have any doubts regarding this question? Regarding any of the things in this question? Have you all understood? Okay. In that case, we can do another problem with 3 balls, okay? This is also very important repeated question, okay? 3 cylinders are piled in a rectangular ditch as shown in figure. The neglecting friction determine the reaction between cylinder A and vertical one. Okay, you will need to find out only the reaction between the cylinder A and vertical wall. The reaction between cylinder A and vertical wall. Okay. Okay, you'll need to find out only this reaction. Only have to find this reaction or A. Okay, draw the figure and question and also write the question. We can solve this question. Okay. It is also very simple, similar to the previous one. Draw a rough figure and write down the question first of all. Okay, have you completed? Shall we discuss? Okay, shall we discuss? Okay, listen. So, this is the first ball and this is the second ball and this is the third ball. Okay. You need to find out the reaction between the vertical wall and ball B. Okay. So this is RB. You need to find out RB. Okay. Also, it is given that the radius of B is 120 and C is 100 and A is 80. And also weight of all three cylinders, that is 30 Newton, 80 Newton and 40 Newton respectively. Then we'll need to consider, first of all, this is the center of ball A and this is the center of ball B, B and A. Okay. So there will be a reaction force between A and B, that is RAB, and also there is a reaction force between B and C because these balls are keep in touch. Okay. There is a contact between B and C and B and A. So there will be a reaction force between these two balls. Okay. So here I am going to draw a triangle, right angular triangle. So if you are considering this is theta 1 and this is theta 2, you will need to find out these two angles. So before that, I am here considering the FBD of A. So what are the forces here? What are the forces acting in A here? What are the forces you will need to consider here while drawing FBD of A? First of all, you will need to consider the weight of the cylinder A. What is the weight of cylinder A here? In question, it is given that it is 40 Newton. Okay. So 40 Newton acting downward direction. 40 Newton. Okay. And also, it is in contact with the vertical wall, left side vertical wall. So there should be a reaction force between the vertical wall towards what? Towards the ball A. So it is RA. Is it right? So you can draw like this. RA. It is acting towards right hand side. Okay. Acting in right hand side along x axis. Okay. It is right. Then also there is a reaction force between RAB. Okay. RAB is acting towards, that is the force, the reaction force of B acting towards A. So you can, this is the line of action of RAB. So you can draw the figure like this. Draw the force like this, RAB. So what is the angle between the line of action of RAB and this x-axis? This is theta 1. This is theta 1. Okay. The line of action and between x-axis. The angle between line of action of RAB and x-axis is theta 1. Okay. Here also line of action of RAB and x-axis taken as theta 1. You will need to find out the value of theta 1. Also it is given that the width of the channel is, what is the width of the channel? It is 360. 360. Also we know from left hand vertical wall to the center A. Center of the cylinder A is what? Its radius. Okay, it is 100. It is also given in our question. And also this from center of B to right hand vertical wall, it is the radius of ball B. It is 120. So what is the distance between from this point to this point? You can take this point as D and this point as E. So what is the distance between D and B? DB. Similar to the previous question, you can find out the value of DB. So what is DB? Yes, 140. That is DB. DB equal to what? Entire width, that is 360 minus 100 radius of A plus radius of B. Okay. So 360 minus 220. Okay. Is it okay? Then that is 2 140. Okay. 140. dB equal to 140. Also, you need to find out what AB. AB equal to, what is the value of AB? Just sum the value of sum of radius of A and B. So 100 plus 120, that is equal to 220, right? Then you need to find out cos theta 1. What is cos theta 1 here? Adjacent side by hypotenuse. So here adjacent side is dB. dB by what? AB. Okay. So that is equal to what? 140 by 220. So what is the value of theta 1? You need to find out theta 1. Okay. So what is theta 1? Find out the value theta 1. Theta 1. Tell me what is theta 1? Okay, 50.48. Okay, 50.48 degree. Okay. Then similarly, you will need to find out cos theta 2. Cos theta 2 is equal to BE by BE divided by what? BC. Okay. What is BE and BC? Similarly, you find DB and AB. In the same way, you can find out BE and BC. Okay. So what is BE here? BE equal to 360 minus radius of B plus radius of B. Okay. That is 360 minus 80 plus 120. 360 minus 80 plus 120. Okay. Radius of C plus radius of B. All divided by, sorry, that is BC. Okay. And BE, okay, BE is 360 minus 80 plus 120. And then what is BC? What is BC? Radius of C plus radius of B. That is simply 80 plus 120. So what is the value of theta 2 here? Find the value of theta 2. Find the value theta 2. Tell me what is the value of theta 2. Sneha.
Yes, ma'am.
What's the value of theta 2?
36.87.
36.87. Okay. 36.87 is the value of theta 2. Then you can consider the free body diagram of, first of all, you need to consider the free body diagram of A and find out RAB. Okay, find out RAB. So what is RAB? How we can find out RAB? Consider sigma fx equal to fy equal to 0. First of all, you need to consider sigma fy equal to 0. From that, you will get RAB because the known value here is in x-axis, that is 40 Newton. It is a known value here in the free body diagram. So you can consider, first of all, you can consider sigma fy here. So here the equation for sigma fy, I will write sigma fy equal to 0 implies sigma fy. The force acting downward direction, that is 40 Newton, is negative charge because it is acting downward direction, and also component of RAB, the component of RAB, it is acting in second quadrant. Okay, right? RAB, you can draw separately if you want. Then components are acting left and upward directions. Okay, so this is theta 1, that is RAB cos theta 1, and it is RAB sin theta 1, right? So here you can write it is positive charge because it is acting upward direction. So RAB sin theta 1. Okay, you can put the value of theta 1 also here equal to 0. From this, you can find out the value of RAB. Okay, find the value of RAB. So in the next step, you will need to consider the free body diagram of, similarly, this free body diagram of B, and you can find out the next value. Okay, you will need to consider free body diagram of B, and we'll have to resolve all other forces. Okay. Okay, we can do this problem in our next class. That is in 6th hour. We can continue this problem. Okay. Or leave, so don't leave the class.